Right, we've cut that hex out in the middle. I think you can see the hex. Now it's going ahead and drilling the holes. These holes have got to be tapped. There's only 2.5 mil. I've got to spin them pretty fast. I don't want to break that bit. I've got it set to do those spot drills, drilling down 1.5 mil at a time, then comes out and clears itself, because the aluminium tends to build up on the drill bit if you try to do it in one hit at that speed. So stop it there. Just finishing off now so that it makes it a bit, I've got to turn it around and put it in the lathe. So it makes it a bit easier in my poor little lathe if I cut a fair bit of it away for a start. So this is what we're making. I'm making a little front end loader for Jed, and this bit we're making now are the hubs. I'll try and get that out. Yeah, that's what we cut out with the mill. Actually, we've done the inside, and the hexagon is because that hubcap comes off. Then there's a nut down there onto the axle, and that big hexagon nut is held onto the axle by a pin, and that's what actually drives the wheel. So it comes up quite good. All those little screw holes line up beautifully, just perfect. So here's the loader so far. You can see her there, there's the front end of it. And the front axle and diff goes through, that's what I'm making the rims for that now. Back axle's done, with a little diff in there. So it'll be a great little loader. It'll be a little beauty, it'll last him a lifetime, this thing. I'll have proper hydraulic rams that I've got to make up yet. I've started. Where are they? I've got them here somewhere. I've started making the rams, and a little hydraulic pump I've got that I'll drive with a model aeroplane motor. That's the end of the ram that goes onto the tube, like so. Cut the tube to length, another end, hydraulic fittings, and away we go. So you should have a lot of fun with it. This stuff was done on the mill too. All the arms and all those bits you can see there were cut out using the mill. And you can see the tabs, well, you can tell the software to leave tabs, like there, and there, and there, and there for that piece, so that when you finish you just press them out with your thumb. And then they're perfect, they're absolutely spot on. You can see the joints there are all tap fits. Alright, there we go. Just a bit here to show you the mill working. There's a stepper motor there. That's driving the x-axis. The y-axis is down under there, and the z-axis up here. You'll see it when it lifts a bit. Not going to. It's travelling around. You can see they're pretty busy, the motors. Able to turn very tiny amounts of force. Right, here's the finished product. I don't get it so you can see it's pretty shiny, but you can see the hex there now properly, and it'll go on the lathe now and spin the back off. I've got a plate made up that fits those holes. They'll be threaded, and then I screw it to that plate, put the plate in the lathe chuck, and I can work on this to turn the inside of the rim down. So I'll just take the bandsaw and take those corners off for a start and put in the little lathe. Screw it up and it'll be finished. Bit of a polish up while it's in the lathe to take those tooling marks you can see in there off, but you can't feel them. They're just marks that the tool leaves, but there's no feeling of them. I'm going to try and post a photo of a clock I made for Anita. Here's a bit of an idea. This was out of wood. You can see there's a turtle, and all those cuts are V cuts. They're on a V, and the male, there's one that was put together. You might be able to see that. So you make another one then where it's a V the opposite way. So it's like, there you go, an implant, what do they call, insert. So the two fit together in the vise. You line them up and put them together. There's that. There, anyway, and you screw it up in the vise with a bit of glue in there. Fill it up with glue, screw it up in the vise, and I'll show you the clock if I can post a photo anyway.